All right, guys, we are back. It is May 11th, 2020. Hopefully you took your moms out somewhere nice, wherever that might be, because everything's closed, but hopefully you treated your moms nicely yesterday on Mother's Day. Hopefully you did not forget that. But today, we're going to be doing something called box plots. You might have done this last year in the 8th grade. So we've already covered dot plots, right? We've talked about mean, median, mode, and the shape of distributions. All right, so as a quick review for this warm-up, why don't you guys name the shape of each distribution, and then label the mean and median on each approximately. So for example, if you think the mean is going to be here, put that as the mean. If you think the median is going to be there, put that as the median, right? If you think it's there, right? And then label it on the diagram. It doesn't have to be exact, right? Just kind of where you think they're going to be, right? The biggest thing is just knowing whether the mean or median is going to be bigger based on the way the distribution looks, right? So go ahead and pause the video and try this warm up. I'd say give it like 4 minutes or maybe less, right? And try not to look at your notes from yesterday, but if you need to look at your notes, that is perfectly fine. All right, so this first one here, this is skewed. Was this skewed left or right? The way we think about it is which side is the tail on, right? Our tail is on the left side, so this is skewed left. This one here is always the easiest because it is symmetrical. And so we call it a symmetrical distribution. Easy enough. This one, the tail is on the right side, so this we call skewed right. All right, next I asked you to approximately label the mean and median. Well, if it's symmetrical, hopefully you guys would agree that both the mean and the median, they're all going to be right here in the middle, right? The median and the mean, right? If you average all the data, the average will be right in the middle because it's symmetrical. If you take the middle number after you organize everything from least to greatest, that should also be right in the middle. So mean and median are going to be the same there. If it's skewed left though, right? Do you remember these values, right? These lower values in this tail here, they're going to drag down the mean. So maybe the mean might be somewhere over here. But the main idea is that the mean should be lower than the median, right? Let's say the median or the middle number might be somewhere over here. All right, so if it's skewed left, well, what gets pulled left is the mean. So like we wrote down yesterday, the mean will be less than the median. All right, think of the Pac-Man. The median's going to be greater. Pac-Man's going to eat that median rather than the mean. And so opposite is true if it's skewed right. Right? Our mean is going to get pulled up by the tail values. Whereas the median, it does not get affected as much by these skews. So there is our median, and in this example, the mean is greater than the median. All right, if you don't believe me as to this actually happening, well, we did plenty of examples yesterday, right? And we saw that occurs each time when we do it. So like we saw here, right? When we had a tail on the right, when we actually calculated it, right, the mean was bigger than the median. When we had our tail on the left side, right, our median was 6 and our mean was 5.5. So let me actually write those in, right? Our mean was here and our median was here. So you can see just when those shapes happen, that's actually how the data works out. The mean is going to be less than the median when it's skewed left. When it's skewed right, the mean will be greater. All right. So today, we're going to organize our data in a different way. It's just another visual representation. So we did dot plots already. You should be able to make a dot plot of this data, of course. but today we're going to make something called a box plot. So to get a box plot, what we need to do first is to get the median. So luckily for us, all this data is already arranged from least to greatest. So to find the median, I'm just going to cross off one from each end until I reach the center. Right, and because there's an odd number of data points, 21, right, I know that I should only have one number left in the middle, and luckily I do, and that number is 20. So the median here is 20. Right, if you had two numbers left in the middle, if you have an even number of data values, right, you just take the average of the two middle numbers for the median. So now we're going to find something called the 25th percentile, which is also called the first quartile. So I'm going to throw like a whole bunch of vocabulary at you, but hopefully it's not too bad, right? 25th percentile, also called the first quartile. And what this means is this is the age that is greater than 25% of the data. So you want like the 25% mark of our data. So the way we do that is, well, isn't this like our 50th percent mark? So what we call the median, that's the 50th percentile. That is another name for the median. Well, if that is like the halfway point, what we're looking for here is like the quarter way point, right? The first quarter, the 20th percentile. So if that's 50%, well, 25% is going to be halfway of our lower half of the data. So what we do is we take the median. This is the median of the lower half. So I'm going to erase all of this crossing out stuff. And I'm going to copy and paste all these numbers here. Copy, paste. All right, and by the way, when you do this first quartile, you do not include the median. Do not include the median. So you'll notice when I copied and pasted, I did not include this 20. We don't include that as part of the lower half. So here's the lower half of the data. I'm going to cross that one from each end. Boom, 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 boom. And I notice 1, 2, 3, 4. 1, 2, yep, cross that 4 from each end. I notice I have two numbers in the middle. So our 20th percentile, or the first quartile, is going to be the average of these two numbers, which of course is 18. And that is going to be our first quartile. Right? That's also called the 25th percentile. That means this age of 18, that's greater than 25% of the data. All right? Next, let's find the 75th percentile. Well, if the 25th percentile was the median of the lower half, well, wouldn't it make sense that the 75th percentile, right, it's going to be the halfway point of the upper half of the data. In other words, it's going to be the median of the upper half. And again, we do not include the median when we do the third quartile. So let me just copy and paste this. And let's just change that word lower to upper. Upper half of our data. So copy and paste. Let's get the median of this upper half. I kind of cheated. And again, notice we have two numbers left in the middle, the average of 25 and 27. It's obviously 26, but let's see the calculation, right? We add the two numbers, divide by 2, and we get 26. So this is what we call the 75th percentile, right? This age is bigger than 75% of all the ages. What was it, this 26? right? That was our third quartile. That means 75% of our data is here, right? And only 25% of the data is more than that 26. That is what we call the third quartile. Right, when we found the first quartile, that was, which 18 was it? 1, 2, 3, right, after 3 18s, 1, 2, 3, right? That there, that was our first quartile. I write it the way I wrote the other one, with an arrow going down. And what that means is, well, 25% of our data is over there, right? Which means 75% of our data is above it, right? The median is the 50th percentile right in the middle. So of course, 50% of our data is below the median and 50% is above, right? Third quartile just means 75% is below, 25% is above. And so another name for that, again, is 75th percentile. That's what that means. It's percentile, not percentage. Right, so I know a lot of vocab, but that's all it is. What's the range? Remember, the range is the max minus the min. Right, again, we're talking statistics here, not domain and range, so it's a different definition. So the maximum age of this retail workers is 52, minus the minimum age is 16, which means there is a range of 36 years. So the difference between the oldest and youngest worker is 36 years. So now when we create this box plot, what we're going to do is we're going to take these values that we found, the first and third quartile and the median, and we're going to plot those points. So our first quartile here was around 18. So what I do is I put like a vertical line floating above the number line at 18. Our median was, what was our median? Sorry, that was 20. So I'm going to put another vertical line here at 20. And our third quartile was 26. So I put another vertical line, right? 26 is right there. I put a floating vertical line above 26. And what I do is I make a box out of that data. Right? So that's the box plot. Sorry, that's the box portion of our box plot. There's more to it. Some teachers might call this box and whiskers, because what we're going to do now is draw out the whiskers of this. So we also need the minimum age and the maximum age. So I'm also going to plot 16 and 52 on this graph. So 16 is there, and 52 is all the way out here. And what you do is you connect them to the box, right? Some people might call this whiskers. So there we go. That's your box plot. And I don't know about you, but I like writing in the numbers myself, just so I know what they represent. That was 16. This was 18. This was 20. This was 26, if I remember correctly, right? And the maximum was 52. So those are the 5 numbers we use to make up our box plot. Again, this number here, that was our third quartile. This number here is the median. This number here, that was the first quartile, right? And again, we got that by averaging the lower half. Not averaging, sorry, finding the median of the lower half, right? The bottom 50% of the data. It's going to give us the 25th percentile, or the first quartile. And that 16 there, that's the minimum. And this 52, that is the maximum. So a box plot's just a really quick way to get a visual without needing to like plot all of the points. So looking at the box plot, how would you describe the shape of the distribution? Well, do you see how it's like really spread out over here? So like if you actually plotted all of these points and you made it like a dot plot, let me actually do that really, really, really quick. Right, we're gonna have 16, 17, and then like a whole bunch of 18s, a couple of 19s, a couple of 20s, a couple of 21s, a 22, a 23, a 25, 27, right? And it gets really spread out over there. So if I made this a dot plot, right, I think you can pretty clearly see that this data is skewed to the right, right? And so hopefully you also see that here. Like all of these guys, they're clustered really close together, right? So most of our data is on the left side, whereas once we get to higher values, everything is spread out. And you can see that by like how wide this portion of the box is over there, right? And how wide this portion of our graph is as well. So this is definitely going to be skewed to the right. Skewed right. Right, and the reason for that is we have longer sections on the right side in our box plot, right? And so one last definition I'm going to throw at you is the interquartile range, abbreviated the IQR. So interquartile, that just means between quartiles. So the interquartile range equals the third quartile minus the first quartile. And so that's going to equal, our third quartile here is 26, right, minus our first quartile, 18. So that is 26 minus 18, that is equal to 8 years for our interquartile range. All right, so instead of max minus min, it's the 75th percentile minus the 25th percentile. So it gives you like the difference in ages of the middle 50% of your data, in other words, right? So that's it. That was a box plot. We need to know how to read one though and draw one. So before we go to analyzing box plots, let's just summarize what we did. So to make a box plot, you need 5 values. You need the minimum, you need the first quartile, or the 25th percentile. The abbreviation for that is Q1. You need the median. You need the third quartile. And we're going to abbreviate that as Q3. And you need the maximum value. Right? So these middle three, they involve a tiny bit of calculations, right? But again, we're just putting stuff in order, right? Getting the middle value, looking at the lower half, getting the middle value, looking at the upper half, getting the middle value. When you do these two guys, right, just make sure you do not include the median when you are calculating. Just say when finding. All right, and then 2 more definitions I want to write on the side here are the range. The range is the max value minus the minimum value. And the IQR, the interquartile range, that is the third quartile minus the first quartile. All right, cool. So below is a box plot of the ages of a randomly surveyed group of people who live in Great Neck. So there are some, it looks like 0-year-olds, so some newborn babies. And of course, we have some elderly folk that looks around to be 90 years of age. So I like writing out the numbers myself just to get an approximation. I think that looks like 70 to me, right? That's the third quartile. The median looks to be around 40. The first quartile looks to be around 25. And that's that. So according to the box plot, how many people were surveyed? Well, that's the thing with a box plot. You can't tell. Right? Look at that box plot. Tell me how many people were surveyed. You can't tell me how many people were surveyed. There is no number. It's not 90. 90 is the age. right? The maximum age. So you can't tell how many people were surveyed, right? Just like looking at this box plot. Well, actually, we should label the axis, right? This was the age of retail worker, right? Looking at this, right? Again, you can't tell me how many retail workers there are from this data, right? But of course, if you look at the actual numbers we use to make the box plot, you can count, right? And you'll see that we have, sorry, all of this, we have 21 retail workers, but there's no way of knowing that just looking at this. So you can't tell. How many people are between 40 and 70 years old? And again, you can't tell. So you can't tell specific numbers, but what you can tell is you can tell percentages. So for example, what percent of people are between 40 and 70 years old? Well, 40 to 70, wasn't this the median? Right, this here was the median. The median is the halfway point. In other words, we can call that the 50th percentile. Isn't this the third quartile? That is the 75th percentile. So between the 50th and 75th percentile, well, isn't this 25% of the data? Right, 25% of people are between 40 and 70 years old. What percent are between 40 and 90? Well, again, this 40, that's the median, that's the 50th percentile. So wouldn't you agree that 50% of our data lies above the 40? So 50%. So what percentage does the rectangular portion of the box plot represent? So the rectangular portion, that's talking about the box piece. Well, the box piece, that goes from this guy, this 25, that was Q1, that was our 25th percentile. So from the 25th percentile to the 75th percentile, well, that's going to be 50% of our data. 50%. All right. So it does not matter how wide a section of the box is. Each section represents 25% of the data. Right? That's 25% of the data. This here, that's 25% of the data. This, that's 25% of our data. This section here, that's also 25% of our data. All right? So even in this previous example, right, this portion of our box plot, it's really huge. That does not mean there are more workers between 26 and 52 years of age. It just means that's really spread out. But that's still only 25% of our workers, right? We'll take a look. That is those guys. That's 25% of the people, right? 25% of the people are in between, again, 20 and 26, so etc. So estimate the following. We already did this, so let's just do it real quick. Median 40, 25, 70. The interquartile range is going to be 70 minus 25, right? The 75th percentile minus the 25th percentile, or the third quartile minus the first quartile. And that is 45. The range is max minus min, which would be 90 minus 0, which is 90. So, did I add that? Okay, I did add it. So, letter F, suppose 40 individuals were surveyed. How many are between 25 and 40 years old? Well, like we said before, we knew 25% are in between 25 and 40 years old. So if now we know the total number, well, now I can actually tell you how many people are in between 25 and 40, because all I have to do is take 40 and multiply it by 25%, right? So take 25% of 40. And the way we do this, if you do not know how, is we change 25% to a decimal and we multiply it by 40. So 40 times 0.25, that's going to equal 10 people. All right, now let's pretend that there were 200 people that were surveyed. How many are in between 0 and 70? So 70 is our 75th percentile, 0 is the minimum. So that means 25%, 50%, 75% of people are going to be represented in that age range. So what we want to take 75% of 200, right, out of our total number. So we do 200 times 0.75, and that equals 150 people. Right, and I think I should write out people here just so we know we're talking about actual number of people and not a percentage. Right? So number one here, let's practice. Probably a good idea. I recommend at this point, pause the video, try numbers 1 through 5 here and this extra problem on the last page. And then you can check with my work. So pause the video. All right, go. And let's do this real quick. All right, so identify the 5 number summary. So we're just writing out those 5 numbers. And so again, those 5 numbers are going to be composed of the minimum, the first quartile, the median, the third quartile, and the maximum. All right, so just reading off the box plot, I'll copy and paste this for my second one. And the numbers we should be getting are like that. All right, so I just wrote out the numbers from the table. Number 2, what percentage of days did the Oakdale Science Museum have between 14 and 30 visitors? So 14 visitors over here, 30 visitors over there, all right? Even though that's like half the total length, well, that is 75% of our data, right? Because that goes from the first quartile, which is the 25th percentile, to the maximum. So on 75% of days, they had between 14 and 30 visitors. Which museum has the larger interquartile range? Well, we can just look at the size of the box, right? Literally, because that is the interquartile range. The interquartile range is the Q3 value minus the Q1 value. So whichever one has the bigger rectangular portion will have the larger IQR. So that is the Oakdale Museum. If you want, you can actually do the calculation, right? 28 minus 14 is going to be bigger than 20 minus 14. Which museum would you say has a greater variability in the number of visitors? So which one is like less consistent, right? Greater variability means like less consistent. Like there's a greater spread in the number of visitors. So we can take a look and see which one has, or it's more spread out. And that looks to be the Oakdale Museum, right? Especially because like this box part, it's really spread out. So that means like they're not having like the same number of visitors every day. Whereas if you look at the Washington Museum, right, this part's really clustered close together. So they're getting like between 14 and 20 visitors 50% of the time, right? So that's pretty consistent in my view, whereas Oakdale Museum is much less consistent. So I would say Oakdale has a greater variability. And 2 ways you can measure variability, which we'll talk about later, is using the range and the IQR. So we can say it has a larger range and interquartile range. Right, so there's a larger difference between the minimum and maximum ages, right, and also between the 75th percentile age and the 25th percentile age. And all of that just suggests it's less consistent overall as to the number of visitors it gets each time. Right, and lastly, describe the shape of the data distribution for each museum. I would say that Washington Museum looks pretty symmetrical to me. The median looks to be pretty close to right in the middle. Right, the whiskers at both ends look to be about the same length. So I would call Washington Museum symmetrical. And looking at the Oakdale Museum, well, I notice this is a lot closer together, whereas this is much more spread out on the left. So that definitely looks to be skewed left to me, right? Has a longer tail on the left. Right. And lastly, the box plot suggests that 25% of gyms in Shanesville have more than what number of gym members? The box plot suggests that about 25% of gyms in Shanesville have more than what number of gym members? So this is a box plot of the number of gym members at each gym in Shanesville. So the median, right, or the 50th percentile is 64. So 50% of gyms have less than 64 members and 50% of gyms have more than 64 members. So what percentage have more than 25%? So it looks like that's going to be at 70, right? Because that is more than having 70 gym members. So the box plot suggests that about 25% of gyms in Shanesville has more than 70 gym members, right? So this is not asking for the first quartile. It's not the 25th percentile, right? It's asking, again, what's the number of members it takes so that 25% of gyms have more than this number of members, right? It's, sorry, I worded that really badly or really poorly, but yeah, only 25%, right? This is 25% of our data would have more members than 70 members. All right, so again, that's going to be it for today. That is box plots. Take care, guys, and see you guys next time.